All right. Thank you, everyone. Todd Underwood with my co-conspirators, Jim Cowie and Tony Capella. This is some thought experiment plus some initial work that we've done to build on some of the previous work some of you saw presented at NANOG 49 in San Francisco. So that work was prefixes as probabilities. It was a modest proposal to radically extend the life of IPv4. The general notion, just to remind people, because if you can't remember that talk, this one won't make much sense. There's a good chance this one won't make much sense anyway. But the basis of that talk was that we would allocate unique resources only to those who need unique numbering resources, and to do so at a very, very, very steep premium. And then recognize the reality that the internet as we know it already has lost uniqueness of addressing, right? There's NAT, there are collisions, there's hijacking, there's Anycast. All of these things are addresses in the internet being reused. And so we propose simply extending that to canonicalize that in the address assignment system, so that if you didn't really need a unique address, you could get an address that had, say, a 23% probability of being unique. And we had a number of systems. Anyway, there was good work on that. Keep that in your head, because that's what we're building on. People were told, you know, that. So what happened was we gave this talk. I had a lot of discussions afterwards. And there were some legitimate criticisms. One of them was that prefix collisions, when they happen, would be inobvious. Traffic goes to where it goes, and something might just be working and then not working. And this is obviously true. Like, so this is something that we need to think about. I mean, obviously, that was our intent, that you might not get fully functional prefixes all the time. But we hadn't really thought about strategies for mitigating that. So this is an important part of what this work does. So transmission errors and redirection are difficult to detect, and we provided no mechanism for safely mitigating them. I also heard a lot of people say, this can't possibly work. That's obviously nonsense. So there's additional work. One of the wonderful, wonderful things about the European Union and China and India and the United States is they fund all manner of research. So there is no idea too silly that has not had a number of important papers published years ago about it, right? So I guarantee, like, go off and sit in the corner and come up with the goofiest thing you can come up with, and I will find you 5 PhD theses that were published more than 4 years ago on that exact subject. So this one is enhanced spread spectrum TCP, right? So the general idea here was specifically addressing topics of privacy and topics of use of hostile networks. But this is good stuff. I mean, this is in fact almost exactly what we need. So we're going to reuse these notions for basic functionality to solve the problem that we've discussed, which is we're going to have these addresses, they'll probably be reused somewhere. What are we going to do then? So here's the problem statement. IPv4 addresses are increasingly rare, and there is contention. We all know this. IPv4 prefixes are no longer quite as unique as they used to be. There's a comment there. Niels, you got that? Yeah, right there. That was for you. Thanks. Will Hargrave did that one. IPv4 and IPv6 are going to be coexisting for some time unless IPv6 goes away. Lorenzo's told me it's not going away, but anyway, there's still hope. And there's currently no mechanism for collapsing the matrix of possible or probable adjacencies across a set of prefixes or protocols into a usable TCP connection, right? So there will be math later, and I'm sorry, but there's going to be a little bit of math, but it's going to be okay, and Tony can explain it to you later. Okay, so continuing the problem statement, right? If you host content on a single IPv4 prefix, this is serious vulnerabilities. It can be hijacked, it can be spoofed, your traffic can be stolen, man-in-the-middle attacks, right? Like the YouTube Pakistan thing, and they're just endless. I mean, F-root, absolutely. This is only a security problem as long as you define it that way, as long as you weren't expecting your prefixes to be hijacked, right? Okay? So prefixes as probability has solved the problem of address allocation, but it has not solved the problem. It didn't provide graceful degradation. This is a very similar problem to what radio already has, right? We've got this unreliable set of mechanisms, and we need to provide reliable transport across this. So we're going to use a fix borrowed from radium and spread spectrum technologies to create prefix and path agile TCP stack. So here's the proposal. If you can, I'm sorry. All right, so We're just going to say sparse matrix, and we're going to get through this, and it's going to be okay. I know it's lunchtime, but we're going to get through the math. Just a few things we're going to point to. So if you consider addressing to be a sparse matrix representing minimum entropy between a set of endpoints that want to communicate, then your central problem is convergence. How can we converge on a set of these that will work for you and I, or on one that we can then move later? So the conventional model is push. I just tell you, here, use this, and you use it. This doesn't scale particularly well. So things like Lisp, and I think it's called Sham6 and 6rad or something. Anyway, those are all more of a pull model, like here, I'll decide what I'm going to use. So our proposal is to use multiple in, multiple out techniques to probe all of the possible source address destination paths, including even IPv6 if you don't have internet and you want to use IPv6, that's fine too, right? So here's something, ongoing discussion, right? So you're aware of this like smart edge, dumb core. That's sort of the mantra. That's where we come from. That's like what we believe in. This widens that gap considerably, right? So now there's a prefix agile edge and a stochastic core. The core doesn't really exist in any strict sense. It exists in a series of probabilities that need to be probed and calculated, right? So this is fantastic. And the edge, essentially, it's almost like a Schrodinger's network. The edge creates the core by virtue of the probing selection strategy, right? So this is fantastic. All right, so all of these, Jim Cowie came up with the term the location oblivious spectrum technologies. So this enables probabilistic clients and servers to find each other and build reliable communication. As I said, you would simultaneously explore, so that you would have multiple endpoints bound on multiple prefixes on each client, and then simultaneously probe all the A and quad A records. This will use math to reduce the collision rate associated with a prefix. And then the IPv6 transition, instead of being an undefined transition to an incompatible network protocol, it becomes a probabilistic path, right? Over time, as people roll out new networking technologies to replace the internet, then you'll be able to use those on your internet-connected devices. Okay, so this is one of Tony's slides here. I don't know what to tell you. The internet is an unknown lossy channel. There's lots of academic work on this. Hosts are now represented as sets of transmitters and receivers. The H of LS estimate is, anyway, yeah. Tony's available afterwards for questions. Okay, yeah. Okay, yeah. So just a quick comment on path detection dynamics. So some terms we're using in this work. So endpoints have exits and entries, and a path is a mapping between an exit and an entry. And an endpoint address receiver is a subsystem for detecting a functional path. The selection weighting availability graph, or the SWAG, is the data structure that stores the weights, including 0, right? Because some of these paths may not work. There's an orthogonal vector entry receipt or an orthogonal vector exit receipt, which is the algorithm for adding a path to the SWAG. And then there's a backup entry exit network dynamic, which is the algorithm for weighting and constantly reweighting. You don't want to visit these once. You don't want to like land on a path and have it go away. Right, so the availability of a received size entry or exit is dependent on the backup entry network dynamic in the orthogonal vector entry receipt. And that works the same for exit, by the way. So I know this was fast. Just a couple comments about future work. There's a lot of unanswered questions. I have some, you may have some as well. So we need a proof of concept on the original work of prefixes as probabilities. Professor Levy has promised that he will be doing some work. He mumbled something about 7206s and time zones and switching things on and off. And so that's going to be work. We need a refinement of the SWAG system, better modeling of the loss metrics, and some prototyping and real-world implementations. And if there are any questions. Thanks.
How are there any questions? Okay.
Lorenzo Caridi, Google. I think this is great work. I see strong parallels between your work and the Happy Eyeballs work that the ITF is already working on. So I really suggest that you take this to the ITF, and so we can standardize it, and we don't want non-interoperable implementations of this, right? Because we have all this probing going on, and I think we should really standardize it and move forward with it.
So no non-interoperable probing, I understand.
That's right.
Mark Coster's over in the corner.
Mark Coster's Aaron. Is this thing working?
Yes.
Okay.
Yeah.
Get closer? Okay, I'll eat it.
Probe it. Taller.
Probe it. Okay. So actually, this is amazing breakthrough work. Thank you so much, Todd. So my question is, okay, as you come up with this, what sort of core services does one need to provide from this sort of venture? I'm thinking of framing and dealing with clocking, for example. How would you actually deal with that?
Yeah, so Tony and I talked a little bit about it. One of the things is that this actually, it's possible to do this with no clocking in particular, right? So you can do it completely clockless synchronization mechanism. Tony was doing it, that also had math, so I'll admit to not following it entirely, but he's the other tall, bald guy, so you should go talk to Tony. But thank you. And we're really looking forward to some support in Aaron for the original multiple addressing scheme and for this. So appreciate the support, Mark. Thanks.
Oh, you're welcome.
Dave Temkin, Quickster. So math is really hard. I really only understand how to multiply like 44 cents at a time. But I was wondering, is there a way that I could possibly use this to deliver more than 100% of the available bandwidth in any country at any point in time?
So Jim and I talked.
Just stop. You don't have to answer that. That's just dumb. Just sit down. Yes.
Thank you, Jim.
So, Chris Luke, Comcast. So we've actually been looking at work like this for real. We actually took... But we were going down the road of using an infinite improbability drive to do this. I was wondering if you've done any interoperability studies for this.
No, the work is, we need to do significantly more sophisticated modeling than this, so not yet. But thank you for the suggestion. We'll take
Well,
a
we
look
were
at
just running on the lines that if your packets are everywhere all the time, you wouldn't have to worry about the probability of it actually showing up anywhere.
Well, that's right. So that's right. One approach we looked at and we discarded simply because we couldn't. There was also math, but it had something to do with every packet can be almost everywhere, but not all packets can be everywhere at all times. Anyway, we can discuss
This is
it
sounding like high-level physics shit now.
Yeah, well, exactly. And then Tony's like, blah, 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 heat signal, blah, blah, blah. You're going to burn up the universe or something. I don't know.
We'll put this in a working group, and we know there will never be any usable results for years to come.
Well, I think that's actually what Lorenzo just suggested was a very sophisticated social sabotage.
Right. I think this came up at the FCC as well.
Avi Friedman, Server Central. To answer Mark's question, my home network, which consists of half proteons and half microrouters, uses a protocol called directed inter-carrier clocking. So I was thinking that the thing that you need to make ARS most useful is a little bit of dick.
And on that note, it's almost impossible to argue with that comment, so I think we're done here. Anybody who would like to contribute to this work, please come find me or Jim or Tony later. Thank you very much.